This is chapters 9-5 and 9-6, trigonometric ratios and solving right triangles. Please copy your cuts. All right. On this particular problem, we have triangle ABC such that we have a right triangle. And we're asked to find the value of x. X is here, AC. What are we given? We are given theta, or they're telling us to reference and look at angle A. Angle A is 5 degrees. This is our angle measure here. And we're also, in reference to angle A, what are we given? This leg here, this BC. And in BC, in reference to angle A, is which leg? It is the opposite leg. So we're given the opposite leg, and we're given theta. We're asked to find the value of x. To do that, the first thing we want to do, first think about which angle we're basing all of our points from, and the angle we're referencing is angle A. The second thing we start doing is labeling all the sides that are opposite, adjacent, and hypotenuse. We've already labeled the opposite because we recognized it. This leg AC, or where we're trying to find x, is the adjacent leg. It's next to, and of course opposite to angle C is the hypotenuse. Alright. Now, third thing we do is try to figure out which trig function is best to find x. Well, I know I need the adjacent leg. I'm given the opposite. I'm given the opposite, which is 3 feet. I'm given the opposite. I know that number. I'm also given theta. Okay? I need adjacent. Which one has opposite and adjacent both included so that I can find it? That's going to be the tangent. Tangent theta is equal to opposite over the adjacent. What do we have? We know theta. Theta is 5 degrees. That's why I chose tangent. We know the opposite leg. It's 3 feet. What we're trying to find is the adjacent leg. So that's the only thing we're trying to find or that's missing. That's why this one is good. Now, you could have used sine. Sine is the opposite over the hypotenuse. Again, you're given theta. Theta is 5 degrees. You're given the opposite leg, which is 3 feet, but you don't know the hypotenuse. That would have been more steps you would have had to work because you still don't have x. You would have been given the hypotenuse, solving for sine. However, we don't necessarily need the hypotenuse. You could use Pythagorean theorem after that, but that's doing more work. I would have used tangent to go forward. All right, so let me clear this here. I like tangent. Again, tangent says opposite over adjacent. I chose tangent because I have theta. It's 5 degrees. I also have opposite leg value, which is 3 feet. And I'm only missing one unknown, which is the adjacent leg, and which is also what I need. So here it is. Tangent of A, because that's the angle I'm referencing, tangent of A, which is 5 degrees, is equal to opposite over the adjacent. Now, by substitution, what is the measure of angle A? Tangent of 5 degrees by substitution is equal to tangent of 5 degrees is equal to opposite over the adjacent. Okay? Now, in your calculator, tangent 5 is a real number. You have to take out your calculator and you plug in that value. You go tangent 5, and it's going to give you a real number. Make sure you're in degrees. Okay? I get 0.8748, and it goes on, and some more, and some more. Okay? So tangent 5, this is a real number when you have to use your calculator, and you need a trig function and calculator in order to be able to do that. And once I plug in tangent of 5, tangent 5 is equal to, I just substituted here. Opposite leg was, or is, 3 feet. The adjacent leg is x. Okay? Tangent 5 is what? We just plugged it into the calculator. The tangent of 5 degrees is equal to 0.0874. the opposite leg is 3. The adjacent leg is x. Now, we should know how to solve from algebra, pre-algebra, solve for x. To solve for x, all I'm simply going to do here is I need that x out of the denominator, so I'm going to multiply both sides by x. That will drop out. And now I'm being left with 0.0874x equals 3. Okay? I need this x on the side by itself, so what do? We divide both sides of the equation by 0.087. And this will drop out, and we're left with x equals 3 divided by 0.874. We just take that in our calculator. 3 divided by 0.0874. 88, that whole number up there. And what do we get? 34.29 or 34 and 29 hundredths if we're rounding. And x equals 34 and 29 hundredths. So I come and plug this back in. X is equal to 34 and 29 hundredths. We're going to try another one of these. Let's find the missing side lengths. X and Y. Given right triangle ABC, where A is the right angle, C is theta, which we're referencing, which is a 30-degree angle here. It's a 30, 60, 90. Okay? Again, first things first. We're only given one side length. So normally we can use the Pythagorean theorem, but we're missing 2 sides, so we can't use the Pythagorean theorem for this right triangle. We use the trig identities, sine, cosine, or tangent. Okay? Now, first thing we do is think about which angle we're going to base all our points from, and that angle is going to be C, because theta is equal to 30 degrees. Okay? Second, start labeling the sides that are opposite, adjacent, and hypotenuse in reference to the angle we're talking about, which is C. So, what is side X in reference to angle C? That side is adjacent. And what is Y? That's going to be our opposite side. Now I'll start thinking sine, cosine. Which one is going to work to help us find X and Y? Which brings us to step 3. Which is the best trig function to find X or to find Y? Okay? And if I'm looking for X, I say to myself, okay, that's the adjacent leg. Which one has the adjacent? The adjacent is either tangent or it's also cosine. Now the best thing, you got to figure out, we know it's not sine because sine is opposite, so that's out. If I'm looking for X, that's the adjacent leg. It's either going to be tangent or cosine. Well, what's tangent? Tangent says, remember, it's the opposite over the adjacent. So now I go plug and chug. Do I know theta? Yes. It's 30 degrees. Check mark. That's done. Do we know the length of the opposite side? No. Do we know the length of the adjacent leg? No. So we have too many unknowns. We have 2 unknowns for this for the 3 numbers that we need here. So tangent's probably not going to be a good option there. Actually, it's not. Cosine. Cosine includes adjacent. What's the leg comparison for cosine? Adjacent over the hypotenuse. Well, for cosine, we go back and we walk through it. Do we know theta? Yes. We're referencing angle C, and it's 30 degrees. We have theta, it's 30 degrees. Do we have the adjacent leg value? No. We don't know that. Do we have the hypotenuse? We do. It's 8. So this is good. We're missing only 1 unknown. So it looks like cosine is going to help us find the adjacent leg's length. That works best. Remember, sine didn't work because sine is opposite over the hypotenuse, and we needed adjacent. So these were the best choices. We found tangent was no good. Didn't work. Okay? Now that we've discovered we want cosine, we move further. Cosine of 30 degrees, because theta is 30 degrees. Cosine is adjacent over the hypotenuse. Okay? What's the best trig function to find y? Well, I'm going to put y in a different color and put it in red. Y deals with opposite. Which legs give you opposite? That's going to be sine, which is opposite over the hypotenuse. Tangent also has opposite in it if I'm looking for y. Tangent again is going to be opposite over the adjacent. So let's go here. Let's try and find if we're trying to find y. Okay? Do I know theta? Yeah, we do. It's 30 degrees. Do we know opposite? No, that's what we're trying to find. So that's not going to get it. Do we know the adjacent leg? No. Do we know the hypotenuse for sine? Yes, we do. So this one looks pretty good right here because we only have one unknown, the opposite. So I use sine in order to find y, and I use cosine to find x. Okay? So now we've determined which one we want to use. Here we are. All right, so the sine of 30, this one we're using to find y, and this one we're using to find x. Okay? Here we are. If I'm finding y, and actually I'll come over here and put cosine. Let's do the x. Cosine of 30 degrees, and we know cosine is opposite over the hypotenuse, and the opposite leg, adjacent over the hypotenuse, and our adjacent leg is x, so I'm going to say x. What's the length of the hypotenuse? 8. So I'm going to substitute this in here. Over 8. Remember, cosine 30 like tangent is going to be what value? Okay, just put it in your calculator. The cosine of 30 degrees gives us some number. You put that right in there, 0.866025. Okay, so I come in here. I have a real number for this now. Okay, this is going to be 0.866 equals an x over 8. And I can solve for x. How do we do this? This is an old school pre-algebra algebra problem. Okay, that means we're going to multiply to get that 8 out of the denominator. Multiply both sides by 8. That will drop out. We're going to be left with x. We're going to be left with x equals some number. How do we do that? Multiply right in our calculator. 8 times 0.866. And we get a number that we get like 6.928 or close to 7. Okay, so this is approximately 7. And I'm not sure if I use units on it. Did I put feet? Nope, I just left it as a number. So x is equal to 7. Okay? Now, I can tell you can cheat. You can use the Pythagorean theorem. A squared plus b squared equals c squared. Or you can continue using the trig function. We've already determined what we want to do to solve for y. And to find y, we use sine. Okay? To find sine. Okay, remember the opposite leg was y. Opposite to the c is y. Over the hypotenuse, which is 8. So the sine of 30. Now we're solving for y. I'm switching and left x alone. So the sine of 30 equals y over 8. This sine 30 is a real number. All we do is come in our calculator and put in the sine, S-I-N, 30 degrees. We get a number such that we get a half or 5/10. Okay? So here it is. Sine 30 is equal to 5/10 equals y over 8. We need y on the side by itself, so we need to multiply 8 on both sides to get this 8 out of the denominator. That will drop out. 8 times a half is going to be 4. So 4 equals y. And now we found the value of y. Okay? Come up here. Y equals 4. All right, and this is part 2 lesson.